Hi guys, my name is Robert Feranek, I'm from FedEvel Academy, and in this video we are going to speak about xSignals in Altium Designer. How the xSignals can be useful? We can use them for length matching. Why would we need length matching? We may need length matching when we will be following some rules, for example, when you will be doing memory layout. What are the rules about? If you are, for example, doing fly-by topology memory layout, which is here, the rules, the length matching rules, will tell you that, for example, all the signals in the address command control group, so the signals like address 0, address 1, address 2, 3, and some other signals, which are routed between the processor and the first memory chip. All these signals in this group, they need to have very similar length. So we need to be able to measure the distance between the processor and the first memory chip. And then the rule will also say that all the signals in this address command control group routed between the processor and the second memory chip, they again need to have very similar length. Without the xSignals, it's quite difficult, because without the xSignals you cannot specify in Altium, or you cannot tell Altium to measure the distance between specific chips. But that's exactly what is the xSignal about. These xSignals, they are kind of virtual nets which you can use to measure distance between specific chips. If you like, you can try everything what I'm going to show in this video. You can try it by yourself. For the demonstration, I will be using our open source project. For the fly-by topology, I will use OpenREX board, and to show you the xSignals in the T-branch topology, I will use IMX6REX board. So if you like, go to our imx6rex.com website and download the full complete Altium project, open it and play with it. Open the OpenREX board, this one, click on PCB panel and select xSignals. As you can see, there are no xSignals at this moment. We are going to create them. Click on Design, xSignals, Run xSignals Wizard. Next, we would like to create xSignals for DDR3 interface. If you are not sure, keep or use these numbers, which I have here. Data bus width in our case is 8 lines, address command control, length matching tolerance 20 mils, data byte, length matching tolerance 10 mils, clock differential pair length matching 5 mils. Next, the source is processor U1 and the memories are U2, 3, 4, 5. Next, Altium automatically recognizes its fly-by topology, and when you press Analyze Syntax, it will suggest how to create the xSignals and how to create the xSignal classes. So the first class, address underscore pp1, will include all the address command control signals between U1 to U5. The second class will create the xSignals between U1 processor and U4, that's the second memory chip, this one, then from the processor to the third memory chip, and from processor to the fourth memory chip. Next, now it's going to suggest xSignals for data signals. I would like to reorder this a little bit, because usually for data bank 0 I would like to have the bits from 0 to 7. At this moment, Altium is suggesting the bits from D48 to D55. So I go back, I will reorder this a little bit, next, and analyze again. Okay, this is what I like. So data bank 0 xSignal class will include data 0 to data 7 bits. Data bank 1 is for data 8 to 15. Yeah, 2 is from 16, 3 is from 24, 32, 40, 48, 56. That's correct. Finish. Cancel. So let's have a look what Altium has created. Here are all the xSignal classes. If I click on this first one and I select, for example, A0 xSignal, you will see that Altium automatically selects only the part of A0 signal which is connected between the processor and the first memory chip. And it not only recognizes this part of the track, it also measures distance between the processor and the first memory chip. It's here 2360 mils. If I go to the second class and I select A0, Altium recognizes the part of A0 track which is connected between the processor and the second memory chip. It also measures the distance. This is between the processor and the third memory chip, processor and the fourth memory chip. This is exactly what we need for a length matching. Recent Altium versions, they also support the length in package. Here at this moment it's 0. But if your chip manufacturer provides this information, if they tell you what is the length inside the package, you know, the length between the silicon to the pad inside the chip, you can use this number here, and Altium can automatically add this length in the package and calculate the correct total length of the track. The xSignal wizard, it automatically created also the xSignal classes for data groups. Here is data group 0, 1, 2, 3, 4, and all the others. And it also, what is very useful, created the rules, length matching rules for these xSignal classes. Design rules, high speed, match lengths. These are all the rules created automatically by the xSignal wizard. The first one specifies the maximum difference between negative and positive signal in differential pairs, which are used in the xSignal classes. These are the rules which specifies the maximum difference between the shortest and the longest signal inside data groups, data xSignal classes. And these are the rules which specifies the maximum difference between the signals inside the address command control group and between the processor and the first memory chip. This is the rule which specifies the maximum difference inside the address command control signal group between the processor and the second memory chip, third memory chip, and the fourth memory chip. Yeah, the maximum difference is 20 mils for these address command control signal groups. This is 10 mils and this is 5. You remember these numbers from the wizard. How this is going to be useful? We can use these rules for checking our memory layout, and also we can use these rules for the interactive length tuning. This board, what we are using as an example, it is fully routed and fully length matched, so you cannot really see any signals failing. I'm going to show you how it will look if one of these signals is not properly length matched and how you can fix it. First, I'm going to unlock all the signals because they are locked. And then I will make one of the signals shorter and show you how to use the interactive length tuning to fix it. Let's say we would like to make this ODT signal shorter on the bottom layer, somewhere here. And Altium immediately said there is something wrong with this signal. Because of this yellow background, you can see that this signal is not properly length matched. You can select it and use the tools interactive length tuning to length match it. Yeah, and it's fixed again. Okay, this was something what I call demo for marketing. In reality, you need to be a little bit more careful. You need to use some steps to do the length matching, and you need to use the correct rules. In this next demo, we are going to use the ODT signal again, but this time I made the signal shorter between the processor and the first memory chip. I made it shorter also between the first and the second memory chip, the second and the third, and the third and the fourth memory chip. So we need to add a little bit of length on every segment of this track. We are going to start with this underscore pp1 xSignal class. So click there, select the ODT signal, click on Tools, Interactive Length Tuning. This is very important. You need to press Tab and select the right rule. We would like to use this underscore pp1 rule. What is the difference? What do you think? Why we need to select this specific rule? Because if we don't select this rule, Altium will try to add to this part of the signal all the missing lengths which are removed from the track which is between the memory chip 1 and memory chip 4. So it will try to add much more length than it is required for this. And if it does, then everything will be wrong. I will show you. If I select this rule, have a look. It tries to add only a little bit of wave. If I select this rule, the waves are much longer, see? And it's still red. So I select this pp1 rule, OK, and click. If you have a look, the ODT signal is correctly length matched in the underscore pp1 group. Now select the pp2 group and try to length match it. Tools, interactive length tuning. Again, what is important again? Press Tab and select the correct rule. This time you would like to use this underscore pp2 rule. OK. Click. ODT signal in the pp1 and pp2 net xSignal classes is correct. We still need to add the length here. Press Tab, select the correct rule, and here it is. I changed the... Did you see what I did? It was starting creating waves one direction, but I wanted to do it different direction. I will do it again. so you can see it. Tools, interactive length tuning, tap, select the rule, press Y, you can change which direction the Altium will start drawing the waves. See? Now the first wave goes to the right. Now the first wave goes to the left. Sometimes it's useful. And do the length matching in the _pp4. And then check if everything is correct. Stop. There is only one rule now. And do it. Okay. Watch the ODT signal. In the _pp1, correctly length match. _pp2, correctly length match. pp3, correct. pp4, correct. Yeah. This is the way how you can do the length matching in the flyby topology. You need to go in the steps and use the correct rule. In reality, when you do layout for flyby topology, there are some techniques which you can use, and the layout will be much easier and much faster for you. And you don't have to do this individual length matching between every memory chip. For example, what you can do, you can draw the tracks between the first memory chip and the second memory chip. Only tracks between only these two memory chips. Length match them, so make all the tracks between these two memory chips exactly the same length or very similar length. And then simply copy and paste these tracks also between the second memory chip and the third memory chip, and copy and paste these tracks between the third and the fourth memory chip. If you are not sure how to do it, have a look on this OpenRex. It was done exactly this way here. And if you do it this way, you don't have to do the length matching between every memory chip because it will be already done. And because you do copy and paste, it is much faster than if you individually route the tracks between all the memory chips. Now the xSignals in T-branch topology. Open the IMX6 module PCB, it's this one, where we use processor with memory chips, 2 memory chips on the top and 2 memory chips on the bottom. These chips, they are connected through T-branch topology, and it means the signal goes from the processor, it splits, then it goes under the memory chips and splits again, and it connects to the memory chips. In this case, xSignals are still useful, but there are some limitations. Let's create the xSignals. Click on Design, xSignals, Run xSignals Wizard. Next, onboard DDR3 memory. Leave these numbers as they are here, or you can use you should use the recommended settings from your design guide. Next, processor to memory chips. Next, Altium recognize its T-branch topology. Analyze. I'm going to reorder these groups a little bit because I would like to have U2 or connection between the U1 and U2 to be in the _pp1 group. So I will change the order here. Analyze again. So pp1 is for the connection between U1, U2. This is U1, U3, 4, 5. Okay. Next, analyze. Now the data groups. So data group 0 is for this data 0 to data 7. That's fine. 8, 16, 24, 48. This is not correct. Data group 4 should start from data 32 to data 39. So these are swapped. I go back, swap it here, next, analyze again. So data bank 0, it's from the D0, D8, D16, 24, 32, 40, 48, 56. Perfect. Finish. Cancel and have a look what the Altium has created. Click on xSignals and on the first _pp1 group. As you can see, this is the group which connects the processor and the first memory chip on the top. Then _pp2, it connects the processor with the memory chip on the bottom, the U1 with U3, pp3. These are the xSignals between the processor and the memory chip on the top here, and this is between the, what do you think? Between the processor and the memory bottom here. Here are also the xSignal classes for the individual data banks. For the T-branch topology, we cannot really use the full power of the xSignals and the rules because, do you know why? Because for the T-branch, we would need to be able to measure distance not only between paths, but also between path and via. Some people do it the way that they create a special via component, they place it into schematic, and then in the PCB they can measure distance between path and this special via component. Or for example, what we use, there are again some memory layout techniques. We very often copy and move part of the layout away from the board. We do the length matching only of the signals which left routed in the board. We use these lengths which you can see here, do the length matching, and once we are happy, we put back the part of the layout which we moved away before. xSignals still will be very useful for T-branch memory layout checking, because these rules can be applied for the final layout, and the rules will check if the layout is correct. But for doing the layout itself, you need to use your own way, what is more comfortable for you. For example, do the via component or move part of the layout away from the board. There are some other useful things what you may want to know about xSignals. For example, how to create the xSignal class. It's very simple. If you have a look on this _pp1 class, Altium automatically included these clock signals here. In your case, maybe you may want to create special xSignal classes only for the clock signals. Right click, add class, clock 0, use filter, DRAM, clock, I will copy it, and move these clock 0 xSignals to the new xSignal class. Okay, and here it is. When I click here, here are all the clock signals. Add clock 1 and copy all these clocks here. Because we moved the clock signals to the special class, we would like to remove them from these underscore pp1 classes. Double click, search for the clock and remove it from the class. Double click, search, remove it. Double click, search, remove. In case you create these special new xSignal classes, you may want to also create the rules for them, but based on the rules what the Altium automatically created, you will know how to do these new rules. I already spent like 3 days recording this video, so I'm going to show you how to create the rules. Design, rules, match length, right click, new rule, double click, clock 0, xSignal class, clock 0, and here is the rule. If you would like to create something more complicated, you can use the custom query, Ctrl C, and use some conditions. Yeah. What I really like is this new button here. Press test the query and you will see the signals on what this rule will apply. Close, OK, cancel. Another useful thing what you may need is to know how to create the xSignals manually. If you have a look on the signals which are inside this group, PP1 group, you may notice there is no clock enable xSignal. And if you have a look on these all xSignals, you will not find it here. So we need to create it. Click on Design, xSignals, Create xSignals. The signal is connected between the processor and the memory chips. And I know it is located in this address command control group, and it is here, DRAM SD CKE 0. This is what we need to create. Search only for the direct connections, and this is what Altium is suggesting. Create the xSignals SD CKE 0 underscore PP1 between U1 and U2. That's correct. Then the other one is between U1, U3, U4, U5. That's exactly what we need. Okay. Here they are. We need to add these xSignals to our PP 1, 2, 3, 4 groups. Double click, search for it. Here it is. I will copy it, Ctrl C, and add this one, PP1, to the address PP1 group. Okay, double click, search for it, add to the group, double click, search, add, double click, and add. xSignals are quite intelligent and they can see through some components. For example, if in your signal there are series termination used, or if you use AC coupling capacitor, xSignal can calculate the length between chips correctly. I'm going to show you an example because xSignals can be used also to length match other kind of signals, not only memory layout. As an example, I will use PCI Express signals in the OpenRex board. PCI Express TX signals are a really good example because there are AC coupling capacitors inside the tracks. Click on Design, xSignals, Run xSignals wizard. Click on Next, select Custom Multi-Component Interconnect, Next. The signals are connected between the processor. Here we select the PCI Express TX signals, and they are connected also to the J15, that's the PCI Express minicard connector. Next, Altium suggests to create xSignals between U1 and J15, and as you can see, it automatically also can see the passive components inside the tracks. Include created xSignals into the class. We can delete this because we will create a new class in the next step. Click Next. Yes, we would like to create the xSignal class. For these xSignals, we are going to call it xSignals PCI Express TX, and we would like to create also the length matching rule because we would like to have them in tolerance 5 mils, and I will name this rule like this. Next, for PCI Express, this is important. Can you see what this rule is going to set? For PCI Express signals, you also would like to do the length matching on individual segments. So on the segment between the PCI Express and the capacitor, and then also on the capacitor and the connector. So this is the first segment between the processor and the capacitors. We would like to create these xSignals. Also, we would like to create the class. Let's call it _C. We would like to create the rule _C, and the tolerance is 5 mils for differential pairs. This is the second part of the track. Let's call it _con, like connector. Oops. And set the tolerance to be 5 mils. Next, finish. Let's have a look what Altium has created. Go to xSignals, and here are the 3 xSignals classes for PCI Express TX signal. The first one is the whole length between the processor and the connector. The second one is only the part of the track between the processor and the capacitors, and the third one is between the capacitors and the connector. If you have a look on the rules, design rules, again, there are 3 rules. The first one specifies the rule for the whole xSignal from the processor to the connector. This is the rule between the processor and the capacitor, and this one is between the capacitor and the connector. Let's have a look how Altium is going to handle interactive length tuning for these signals. I'm going to make the PCI Express TX negative signal shorter in the segment between the connector and the capacitors, and I'm going to make it shorter also between the processor and the capacitors, like this. This is not the proper way how to route the PCI Express signals, but it's good enough for the demo just to see what kind of length Altium will want to add. Click on Tools, Interactive Length Tuning, and do it. Press Tab. Altium only see one of the rules, and this is the correct one. This is the one which will keep the maximum tolerance 5 mils between the processor and the capacitors, so it's correct. For the other segment, click on Tools, Interactive Length Tuning, press Tab. Again, it selects the correct rule, and if we have a look, this one is correctly length match. That's between the capacitors and the connector. This one is correctly length match, no yellow fields here. That's between the processor and the capacitors, and also this one is correctly length match. This is the whole track between the processor and the connector. No yellow fields. So yeah, Altium can handle this. That's really good. There are some things, interesting things what you may want to know about the xSignals. For example, let's say I would like to measure the length of this A4 signal the way that I will measure length of individual segments of the tracks. So I will measure the length from here to here, the length from here to here, the length from here to here, and you understand. Simplest way to do it is mask the signal, select it, click on Reports, Measure Selected Objects. So the sum of all the small tracks in A4 signal between the processor and one of the memory chips is 1866. If you have a careful look, this number is different from what is reported by the xSignals. Here it says it is 1967. Why is there the difference? What do you think? Because xSignals calculates the length more precisely, and for example it includes the length in the vias. I'm going to show you. There is a very nice example. Remember this number 1866. If I measure the length of this second connection of the same signal, it is 1865, so very similar. Yeah, if I measure it here, it's 1867, again very similar. And if I measure it here, what do you think what the length will be? Oops. 1867. So difference between all these four is somewhere between 1865 to 1867, so difference is maybe 2 mils. Yeah. If you have a look on these results here in the xSignals, difference between them is much bigger. These two, they are a little bit longer, 1967, and these two, they are a little bit shorter, 1926. And that's exactly because of length in the vias. Have a look. These two, these are the connections between the processor and the bottom memory chips. Yeah. And these bottom memory chips, they are connected from this track, which is on layer 10. So the distance from the layer 10 to the bottom layer is shorter than these two chips, which are connected, which are placed on the top, and they need to be connected basically from the layer 10 to the top layer. And the difference is approximately 40 mils between these two connections. Another very interesting example to show you how xSignals calculate the length. When I zoom in, you will notice this thin yellow line in middle of the tracks. The length of this line is used for the calculation. What is more interesting is that the xSignals will recognize the shortest way for this calculation. So for example, if I copy this segment, Ctrl+C, and place it here, what's going to happen? What do you think? Have a look. See? xSignals now use this length instead of going this way. And the total length of the track is now shorter, 1907. Before it was 1966. Of course, you still, during the memory layout, you still will need to go through all the signals and check if there are no this kind of loops, and you will need to remove them. But again, it's more precise way of doing the calculation, and it's even more helpful if, for example, by accident you place double segments on your tracks. So for example, if something like this happens, yeah, there is no difference for xSignals, and you can safely trust the number which is here, 1966. If I remove the segment, it is still 1966. When you use the standard length calculation which is here, it makes difference. Have a look. I'm going to show you. Yeah, the length which is reported here is 2963, and if I put this double segment here, it's 2981, so it's longer, but the track really didn't change, but the number is completely wrong. And before the xSignals, you would need to be very careful and go through every segment in your DDR3 layout and look for these kind of situations. So you see the double segments placed on the top of each other. It sometimes happens. And then if you trusted this number which was here, it was completely wrong. xSignals, they fix it. I like it. This is very useful. It saves a lot of time. Two more things what I would like to show you about the xSignals. Select xSignals. If you have a look on these numbers, this length which is here, it is updated in real time. Watch. I start moving these segments and watch the number. 1946, 1945, 1944, yeah, in the real time. You can just adjust the tracks, and in the real time you will see if the track is out of tolerance or if you need to adjust the length. Really cool. This can save you a lot of time. The last useful thing what I would like to show you about the xSignals in this video is about how it can be helpful when you need to select tracks on particular layers. For example, if you are working on an Intel design, they may ask you, or you may want to fill up memory spreadsheet. In the memory spreadsheet, you need to put information about the length of every segment in the memory layout on the particular layers. Before, I had to do it something like this. I selected the layer, and let's say I would like to measure the length from this via to this via. I just selected it, and then manually and carefully I had to deselect all these other segments. And then you could use the measure selected objects 664. With xSignals it's very simple. Just go to the particular xSignal class, select the signal, enable the layer, yeah, and just select it and measure it. 664. It can save you a lot of time. And that's everything for this video. I hope you found it useful. Thank you very much for watching. Don't forget to check out our other videos, and See you next time.